Okay, students, in previous class we are discussing removal of permanent hardness from water. Removal of permanent hardness from water. Already we discussed removing permanent hardness from water by washing soda, Calgon method, ion exchange method. Ion exchange method or permuted process or a zeolite process. Now in this class we are going to discuss removal of permanent hardness from water by synthetic resins method. Synthetic resins method. This is important for 4 marks. So, fourth method, it is a synthetic resins method. Synthetic resins method. So, first of all, you know synthetic resins. Okay, large organic molecules having large organic molecules having large organic molecules having OH alcohol, carboxylic acid, CO, OH, alcohol, carboxylic acid group, or NH2, NH3 plus OH groups. Large organic molecules having alcohol, carboxylic acid or NH2, it is called amine group. NH3 plus OH minus group are called synthetic resins or known as synthetic resins. Synthetic resins. Okay, it is of two types. Cationic exchange resin, anionic exchange resin. Okay, it is of two types. The first one is cationic exchange resin. Okay, the second one is anionic exchange cationic exchange resin, anionic exchange resin. Okay, now we are going to discuss about cationic exchange resin and anionic exchange resin. See, the organic molecules having COOH group comma OH group means alcohol functional group, carboxylic acid functional group, or HSO3 sulfonic acid functional group containing molecules are known as cationic exchange resin. See, these are having cationic exchange resin means these means it is better to use organic molecules having organic molecules having OH, COOH, HSO3 minus organic molecules having OH, COOH, HSO3 functional groups. Okay, organic molecules having OH, COOH, HSO3 functional groups are known as cationic exchange resin. Cationic exchange resin. Okay, so here you have to know organic molecules having functional groups like NH2 amine, NH3 plus OH minus, are organic molecules having functional groups like NH2, NH3OH are known as ionic exchange resin. Anionic exchange resin. Understand, students? Cationic exchange synthetic resins is two types. So cationic exchange resin, anionic exchange resins. So organic molecules having OH, COOH, HSO3 functional groups are known as cationic exchange resins. Okay, cationic exchange resins. Next, here anionic exchange resins. So here also you have to take cationic exchange resins. Okay, here also you have to take anionic exchange resins. Okay, so here cationic exchange is added to hard water. Otherwise, hard water is passed through cationic exchange resin. Hard water is passed through cationic exchange resin. H plus ions are removed from hard water. Okay, see here, when hard water is passed through hard water is passed through cationic exchange resin, cationic exchange resin, and then H plus ions are removed. H plus ions are removed. Okay, see here, COOH. It is a cationic exchange reagent. When it is added to hard water Mg plus 2, then what happened? RCOO taken twice Mg is formed. For H plus ions are removed from this. If you take 2, then it is a balance. In the same way, 2 RCOOH plus Ca plus 2. So here RCOO taken twice Ca plus 2H plus ions are removed. So what I mean to say here, CaMg plus 2 replaces H plus ions. Replaces H plus ions. Okay. For regenerating cationic exchange resin, we have to add H2SO4. Okay. H2SO4 added to cationic exchange resin for regenerating, or for regenerating cationic exchange resin, H2SO4 is added. Okay, H2SO4 is added. H2SO4 is nothing but a sulfuric acid is added for regenerate cationic exchange resin. For regenerate cationic exchange resins, for regenerate cationic exchange resins, H2SO4 is added. H2SO4 is added. Okay, here water molecule H plus is separated. Then here when so 50% purified hard water is passed through cationic exchange resin, then what happened? OH minus ions are removed. When 50% purified hard water is passed through anionic exchange resin, anionic exchange resin, then OH minus ions are removed, and then OH minus ions are separated. Okay, how OH minus ions are separated means NH2 plus H2O gives rise to NH3 plus OH minus. See, NH2 is added to water, then what happened? NH3 plus OH minus. If NH3 plus OH minus is added to X minus, if NH3 plus OH minus is added to which one? X minus. Then what happened? NH3 plus X minus, NH3 plus X minus plus OH minus ions are separated. Okay, NH3 plus OH minus, if you add X minus, then OH minus ions are separated. Okay, here X minus means Cl minus SO4 minus 2, like this. Cl minus SO4 minus 2, HCO3 minus, all these are. Okay, bicarbonates means HCO3 minus 2. Okay, carbonates means HCO3 minus, the bicarbonates means see here HCO3 minus. Okay, these are separated from water. Here H plus ions and here OH minus ions. Then what happened finally? Undissociated. On mixing H plus and OH minus, you will get undissociated water molecule which is a 100% purified. Okay, in the final stage, if you add H plus, finally if you add H plus plus OH minus, H plus plus OH minus, then what happened? Undissociated water molecule is formed. H plus plus OH minus H2O is formed, which is purified. Which is purified. Understand? So this is finally purification, removal of permanent hardness from water. Removal of permanent hardness from water. Understand? See here, this is important process for 4 marks. It is important process for 4 marks. So in this process, how removing permanent hardness from water means by using synthetic resins method. Synthetic resins means large organic molecules having alcohol group or carboxylic acid group or NH2 amine group or NH3 plus OH minus group, that is ammonium hydroxide ions. Okay, so these are called exchange resins. These are 2 types. Exchange resins are 2 types. Synthetic exchange resins are 2 types. Cationic exchange resin, anionic exchange resin. Cationic exchange resins means organic molecules having OH, COOH, HSO3 functional groups are known as cationic exchange resins. Next, when water is passed through cationic exchange resin, so Mg plus 2 Ca plus 2 ions replaced H plus ions. Mg plus 2 Ca plus 2 ions replace H plus ions. So here cations separated, H plus ions are separated. See here, I am taking RCOOH. It is a cationic exchange resin. So Mg plus 2 replace H plus ions. Here Ca plus 2 replace H plus ions. So for regenerate cationic exchange resin, so H2SO4 is added. Okay, then here organic molecules having functional groups like NH2, amine NH3 plus OH minus are known as anionic exchange resins. Anionic exchange resins. So when here 50% purified water, when 50% purified water is hard water is passed through anionic exchange resin, then OH minus ions are separated. So here NH2 plus plus H2O gives rise to NH3 plus OH minus. It is added to hard water, then X minus means anions. So NH3 plus X minus replaces OH minus ions. X minus means Cl minus SO4 minus 2HSO3 HCO3 minus, like that. Okay, so here Here for regenerate cationic exchange reagent we have to add H2SO4 now. Here also for regenerate anionic exchange reagent we have to add sodium chloride. Sodium chloride for regenerating anionic exchange, sodium hydroxide. Sodium hydroxide we have to add. For regenerating anionic exchange reagent we have to add sodium hydroxide or sodium chloride. Okay, so this is a synthetic resin method. Synthetic resin method. Okay, so for regenerating this anionic exchange resin we have to add sodium chloride, aqueous sodium chloride, that is nothing but a brain solution. Brain solution. Okay, so this is briefly removing permanent hardness from water by synthetic resin method. Synthetic resin method. So you have to know finally how many methods for removing permanent hardness from water means. First one with washing soda, second one Calgon method, third one ion exchange method is nothing but a permuted process, and fourth one synthetic resin method. See here you have to know for a regenerate anionic exchange resin, so NaCl, note for regenerate anionic exchange resin, so NaCl is added. Anionic exchange resin, NaCl is nothing but a brain solution. Brain solution how to add for regenerate anionic exchange resin. So it is a briefly water structure. In this it is a hydrogen and its compounds. In this chapter we discussed H2O preparations, and H2O preparation is nothing but that is a natural source of compound. So here H2O chemical properties and some physical properties. Next types of water and types of hardness of water, and removal of temporary hardness of water and permanent hardness of water. Okay, so this is the way we may discuss water. Now water is over. Now water is over. Next we are going to discuss hard water. Is nothing but a heavy water. Sorry, not hard water, heavy water. Heavy water, that is nothing but a D2O. Now the time is going to be finished, so we may leave. Okay, so